In this video, we will look at balanced binary tree coding challenge. It's LeetCode 110. So let's first look at the description. So given a binary tree, determine if it is height balanced. Okay. For this problem, a height balanced binary tree is defined as a binary tree in which the left and right subtrees of every node differ in height by no more than 1. Okay, so we have two examples. So this binary tree, it is balanced, so we'll return 2. And in second example, this is not, so we return false. Okay, so let's look at an example. So let's say that we have binary tree of 1, 2, 3, and let's have 2 more nodes, so 4, 5. And let's manually validate this binary tree if it's balanced or not. We start at the root. So what we need to do is check what's the maximum depth of left subtree and what's maximum depth of right subtree, right? So on the left side, it's 1, 2, and the next branch is here, right? It's also 1, 2. Okay, so the max depth is on the left side is 2, and on the right is 1. So 2 minus 1 is 1. Is 1 less than 1? It is. So we're good. Let's traverse its children. So we move to left child. So now each children needs to also check if it's balanced or not. So we do the same, left and right, it's 1 and 1. And this is less than 1, so we're good. We move to the next node. It's 0, 0, 0, minus 0 is 0. Is 0 less than or equal to 1? It is, so we're good here. Okay. Now let's look another example. Let's add 2 more nodes. So let's add 6 and 7. Okay, and if we start at the root level and check left and right side, and if we only do this without traversing its children, we would think that this is balanced binary tree, right? So the left side is 2 and the right side is 3. So 2 minus 3, it's actually minus 1, but we need to get absolute value. So absolute value is 1. And 1, is it less than or equal to 1? It is, so we're all good. But if we traverse the tree, so we know that here we have so the depth of 1 and 1, so we're good. Let's move on. So now we have the left side, so maximum depth of left subtree is 0, but the right subtree is 2. So 0 minus 2 and the absolute value, so we have 2. So is 2 less than or equal to 1? It's not. That's why we return false. Okay. So this is now not balanced binary tree. Let's talk about time space complexity. For time, it is O of n squared. So we're doing a lot of work. For space, it's O of h for the height. So if we have just like linked list, so all children are left child, so what we would have is O of n actually. That's fine. Now I want you to pause this video and try to code up the solution yourself. Okay, let's do it together. The first thing we need to check if there's no root, right? We just return true. Okay. Now we need to get the maximum depth of left subtree and maximum depth of right subtree. So let's do that. So we will have helper function. Okay. Now that we have left depth and right depth, we need to check if it's greater than 1. Greater than, or yeah, greater than 1. So if it is greater than 1, we just return false. If everything is good, we just traverse its children. And what we're doing here is like every recursive call needs to be true in order to then the final value be true. See, right? True. If any of the recursive call returns false, we will get we will return false. So we don't have balanced binary tree, right? And the final thing we need to do is just implement the helper function. Okay. So if we have no root, what do? We just return 0. But if there is a root, we just add 1, so for the current depth, and just recursively traverse the tree, and we need to get the maximum value. Okay. So it worked. That's great. I hope this helped. Till next time. Bye.